Okay, in this video, we're going to be doing Calc AB Problem Set 16. There's a link to the problems and a playlist of all the problem sets down below. All right, let's do a problem. Given that f of x is differentiable with f of 1 equals -5 and f of 4 equals 12, we want to prove that f of x equals 0 for some x element of 1, 4. Okay, so we need continuity, and since we were told differentiability, we have that. So f of x is differentiable, therefore continuous. You need to write that down, otherwise people don't know that you know that connection. So now what I'm going to do is I'm just going to show that, f is below 0 and then f is above 0, and then use IVT to make it happen. So since f of 1 is less than 0 is less than f of 4, f of x equals 0 for some x between 1 and 4. How do I know that? I know that because of IVT. It's a really common question, you just got to get used to it. All right, new problem. Given that f of x and g of x are differentiable, and therefore continuous, with f of 5 is 9, f of 7 is -3, g of 5 is 1, g of 7 is 4, we want to try to prove that f of a equals g of a for some a element of 5, 7. I tend to forget to do this for a, and I usually just do it for x, which I think I've done on this problem too. So this is another common thing. You just want to have a certain toolbox of things that you can use on certain types of problems, and this is what I do on this type. I'm going to define a new problem that is the difference between these two. So I'm going to let d of x be f of x minus g of x. Now, I need to show that d of x is continuous, but I know that d of x is continuous because f and g are differentiable, which means f and g are continuous, and since d is just made up of f and g, d of x is continuous as well. Now, I'm going to try to use IVT to show that d of x equals 0. So I'm going to find d of 5 and d of 7 because I have enough information to do that. So d of 5 is f of 5 minus g of 5, 9 minus 1, which is 8. And then d of 7 is f of 7 minus g of 7, -3 minus 4, which is -7. So we have a sign change there. So now I'm going to use IVT to kind of knock this out. So since d of 7 is less than 0 is less than d of 5, I think you should definitely somewhere in your work show the values of d of 7 and d of 5. Don't just assert that that's true. So find those values, unless it's you have to reason your way through it. But here we can explicitly find them. So I already found them, so I'm comfortable just saying d of 7 is less than 0 is less than d of 5. d of x must equal 0 for some x between 5 and 7 by IVT. So that's where I'm saying, I should have done that for a. I don't think you'd ever really lose points on this, but be aware, the question did say a and I did x. All right, so now I need to show that because d of x is 0, f of x equals g of x. So d of x equals 0 means that f of x minus g of x equals 0 because that's what d of x is, which means that f of x equals g of x for some x in between 5 and 7. So that's a good problem, pretty common. Not super, super common, but when it shows up, you should just know how to solve it immediately. All right, next up, we're gonna find the second derivative for y equals sine squared of 5x. So I think maybe we've even actually done this problem before. I don't know, but pretty common to find first derivatives, second derivatives, clean them up, that kind of thing. So I'm gonna do this like I do them. It's a chain rule problem, right? We have the quantity squared. So we have the quantity sine of 5x squared. So there's three functions. There's something squared, there's sine of something, and then there's 5x. So let's chain rule our way through this. So the derivative of something squared is going to be 2 times that thing times the derivative of that thing. The derivative of sine is going to be cosine of that thing. The derivative of 5x, which is that thing, is 5. And that's your answer. That's your answer for dy dx. I'm going to clean that up a tiny bit. And then we need to find the second derivative. So here goes. I'm going to show you 2 ways to do this. But the first one is what I think most people would do. I'm basically going to product rule it. That 10 is just a constant multiple. So I'm going to go dy dx. Nope, sorry. The second derivative, because I think you should never try to read that, is 10 times a big quantity. First, derivative of the second. Don't forget the chain rule. Plus second, derivative of the first. And again, don't forget the chain rule. So we get this. And then this, because it would probably be a multiple choice question, you do want to kind of clean this up. So this cleans up sort of ultimately to 50 the quantity cosine squared 5x minus sine squared of 5x. Now, if you're big on 14 formulas or trig formulas, you know that cosine squared minus sine squared is one of the double angle formulas for cosine. So this should be just 50 cosine of 10x. But if you're really big on that, you might go back to this step and notice that 10 sine 5x cosine 5x is 5 times 2 sine cosine, and 2 sine cosine is sine of 2a. So it's really just 5 sine of 10x. So notice, if you do notice that the answer is a lot faster to get. I would say, like, noticing sine of 2x and cosine of 2x, like when they appear, probably the most important of the trig formulas. Other, like, the Pythagorean identities might be important. I don't know. Those aren't really 14 formulas. Anyway, either way, we get the answer. You don't necessarily need the double angle formulas in Calc AB, or really in BC, to be honest. So I would expect the answer choice to look like the first one that I wrote, but like if it didn't look like the first one, it would definitely look like that second answer that I wrote in yellow. Anyway, that's the end of this problem set. I will be back in the next video to do the next one. Hope this was helpful, and good luck.